So today we're going to be going over some of the limit laws in Calculus 1. So the first one we have is, the first law at least, is the limit as x goes to c of f of x plus g of x. We just distribute that limit and rewrite it as the limit as x goes to c of f of x plus the limit as x goes to c of g of x. Then on number 2, we have the limit as x goes to c times some constant k times some function f of x, and we can just rewrite it as, we could bring the constant out and evaluate the limit of the function. The third one, we have the limit as x goes to c, multiplying it by two different functions, so f of x times g of x. So what we do in this situation is, we just write it as a limit as x goes to c of f of x times a limit as x goes to c of g of x. Then the fourth one, as limit as x goes to c of f of x divided by g of x. We can rewrite it as a limit as x goes to c of f of x divided by the limit as x goes to c of g of x, as long as g does not equal 0. We can write that. So we're going to go ahead and try a couple sample problems and see if we can get these ones right. So the first one we're going to evaluate is the limit as x goes to 9 of x. Well, what we're going to do is just plug in the 9 into x, and we're going to get 9. We're going to start off easy here, so that's going to be the first problem. So the second one is going to be a little bit tougher, but it will make sure we do know our distribution laws. It's going to be the limit as x goes to c, or as x goes to minus 3 of 3x plus 4. Remember, what we're going to do first is we're going to put it into here and put it into here. So we're going to write it as, that 3 is going to be constant, so we're going to write the limit as x goes to minus 3 of x plus 4 times the limit as x goes to minus 3. It bothers you not having a number there, you could just even put 1. And what that's going to give us is, it's going to give us 3, we're going to plug in the minus 3 into x, times the minus 3, plus 4 times 1. And that's going to equal minus 5. And this one right here, this one is a little bit different at least, just because it's a law that we didn't go over. So it's actually, the law goes like this, limit as x goes to some constant c of a constant k, well it's just going to equal k. And that's where we got this limit from. This one right here. We just drag the 4 out front. So let's evaluate some more. That one wasn't too bad either. So this one's going to actually have a y instead of an x. So we're going to say the limit as y goes to minus 3 of y plus 14. So we're going to rewrite it as the limit as y goes to minus 3 of y plus, we're going to drag the 14 out front because that's our constant, times the limit at x or y, let's erase that, goes to minus 3. And like I said, if it bothers you, you can always put a 1 right there. So we're going to plug the negative 3 into the y, so it's going to be minus 3 plus 14 times 1, if you want to put that. You don't even have to put that if you don't want to. I just put it there just for your, just for some of you guys out there. So this one's going to equal 11. That one wasn't too bad. We just got to rewrite the limit in each one of these expressions. And then we evaluate the limit using our limit laws and we get 11. So these ones aren't too bad. I know that this is just beginning with the basic limit laws. So the next one's going to have some different notation as well. Limit as t goes to 4 of 3t minus 14. So we're going to bring the 3 out front. I'm going to rewrite the limit as t goes to 4 of t minus 14 times the limit as t goes to 4. Like I said, if it bothers you, you can always put a 1, but you don't have to. So we're going to plug the 4 into the t. So we're going to say 3 times 4 minus 14 times 1. Because remember, on this expression right here, the limit as x goes to some constant c of k, which is some constant as well, is just going to equal k. And this one's just going to equal minus, let's take a look here, actually minus 2, I believe. That's going to be that limit. The next one is the one that sums some people as well. So we're going to say the limit as x goes to 1/2 4x plus 1 times 2x minus 1. So initially on this one, what I thought was to go ahead and just get a quadratic formula out of this, but from what the textbook states, that's not what they want of this whole lesson. Pretty much what they want is to just get our distribution of that limit into each one of these. So that's what we're going to do. I'm going to say 4 times the limit as x goes to 1/2 of x plus the limit as x goes to 1/2. Remember, we could put a 1 right there, which there is technically one. All this multiplied by the limit, or not that, or we got to bring that 2 out front, so 2 times the limit as x goes to 1/2 of x minus, bring this out here, the limit as x goes to 1/2 of 1. So we got our whole expression there. So remember, we're going to plug the 1/2 in, so 4 times the 1/2 is 2, plus, all this one is just going to be 1. All this multiplied. Remember, we use the limit as x goes to c times some constant k, which in this case 1 is our k. That just equals 1. And 4 times the 1/2 is 2. Then we're going to evaluate this. We're going to plug the 1/2 into x and then multiply it by 2, which gives us 1 minus another 1, because the limit as x goes to c times of k just equals k. And well, this is just going to give us 0. So the limit of this expression is just 0. Do a couple more here. So now we're going to go ahead and try to do some division. So the limit as t goes to 9 of t all over t plus 1. So we just plug our limits in now. So the limit as t goes to 9 of t all divided by the limit as t goes to 9 plus of t, don't forget that, plus the limit as t goes to 9 of 1. Put parentheses. And while on the top we're going to plug in the 9, so we're going to get 9 on top. And then on the bottom we're going to plug in the 9 again into the t, and you get 9 plus 1, because remember, this is our constant k. There's just a constant here, and whatever the limit of a constant is, just that constant. Just remember that. And so this is going to equal 9/10. we just plugged in the limit into the t on top and the t on bottom and the 1. And we got 9 because we plugged in the 9 for the t on there, top. Plugged in the 9 for the t on bottom and kept the 1. We got 9/10. Let's try one more here. So we will try the limit as t goes to 2 of t to the minus 1. Well, at first this one might look a little bit difficult, but what we can do is rewrite the limit as t goes to 2 of 1 over t. And then we go ahead and plug in the limit on top and bottom of the fraction. Limit as t goes to 2 of 1 all over the limit as t goes to 2 of t. What we get is, remember, this one's just going to be a limit of a constant, so it's just that constant. And then we're going to plug in the 2 into the t on the bottom, so we just get 1/2. That's our answer for theirs. So just follow the basic limit laws. I mean, they are pretty straightforward. Just make sure you do your distribution right and bring out the constants out front. And the limit of any constant as well is just that constant. So remember that, okay?